Hello, Alberto. Welcome.
Hello.
Thank you so much for making time to come in and chat with me. It's lovely to have you here in the studio.
Thanks a lot. Very glad to be here.
So, if I may ask, let's jump straight into it. So you haven't been in grid automation for very long, only a couple of years, right?
Yes.
And you were in transformers for a very, very long time.
Yeah, 25 years, yes.
25 years.
Yeah.
Do you want to tell me a little bit more about your story?
Okay. I'm an electrical engineer out of the university, and I started my career in Cordoba as an electrical designer for transformers. And then after that, I spent the rest of my 25 years in the business in transformers. First ABB, then Hitachi Energy. Very proud and happy after 27 years of being in the company, of course. I spent most of my first 15 years working in a factory environment. I love it, really, because as an engineer, you want to see
the
products, yeah, and you want to be part of the manufacturing of the product. So it was very nice experience. Then I moved for 5 years to US. Okay. It was a personal and a professional challenge. Personal from the point of view of giving to my kids, I have 3, the opportunity to learn a different language, growth in a different culture. I mean, to be in the world we are today. It's a global and connected world. And professionally, it was really going outside of the boundaries for me.
And did I hear the Transformers is a bit of a family affair? You worked
with
your brother, is that right?
It's not only me, it's also my brother, Alberto Prieto.
So you worked together, doing the same thing in the same factory?
We were working together in the same factory. There is a good reason for that. My father also, he was an electrical engineer. And he was also engineering manager for this factory for many years. So it was kind of in the blood. So we said we have a transformer all in the blood.
Right.
He's still working with us. He's the technology manager for the View Transformers.
Your brother is?
Yes.
Okay.
We were working together. I was portfolio manager. He was the technology manager. So.
Any sibling fights at any point? Did you disagree? You know how brothers normally have little tussles and...
Yeah, we are very like same personality.
Okay.
So it means
you got on mostly.
Yeah, right. We were coming together many times, disagreeing also many times about the roadmap, about many things. So at that time, it was my mother taking the decision for us. It's really a very special thing to be able to work with your family, with your brother in this kind of company.
You're better than me. I don't think I could. So kudos to you.
Yeah.
Right. So if we can jump into what it is that you do, you are in charge of power conversion solutions. Can you tell our audience what that means? What is a converter?
Yeah. Okay. The name of the GPG, it's clearly explained.
So Global Product Group.
It's a global product group. And the name of the GPG explains really what we do, power conversion solution. So we have a full offering for power conversion coming from the products, the converters themselves, to the automation and digital layer we have on top of that. So we have the capability to deliver single products, but also to deliver full complex systems. Okay. Power converters, they are focused in the solar power conversion, but our specialty is battery storage in the GPG.
So you've got your converter and takes the energy from a PV, a photovoltaic system, and converts it into something that we can use in the grid.
Yes. Okay. I mean, there is in the grid has changed a lot. So if we look back before renewables, it was all AC. Generation was AC, consumption, appliances at home, factories, those were also AC. With the renewables, we started to have a generation in the DC current.
Right.
So this is solar, for instance, this is wind. So we started to have the need to have something to convert from DC to AC. So if you look in the past, it was you have the transformers in the generation, transformers in transmission, transformers in distribution, all across, just to transform the voltage.
Yeah.
To be able to transport the energy long distances and also to be able to transform the energy to be usable at home or in the industries. Power conversion is providing its similar function. So they have to convert from DC to AC, so you can really transport the energy, but also not only renewables, also in the side of the demand. Now we have EV charging, now we have data centers. There is a lot of consumption also in DC. So you have to convert again from AC to DC to be able to consume the energy in the right form. So that's why converters, they were not existing really 30, 40 years ago, and now they are really key in the development of the grid due to the renewables and due to the consumption.
And I guess they'll evolved quite a bit over the time, so they would have stopped being quite analog, whereas today I'd imagine they'd be very digital.
Yes. I mean, at the beginning, the converters were kind of dumb machines.
Right.
Like transformers. Okay, they transform from this voltage to this voltage.
Mm-hmm.
Converter, they were transforming from DC to AC. But really with a very limited digitalization, very limited really way of managing this conversion. Nowadays, you can control everything. So it's key also how you control power plant controller, the controller of the converter, because then you can play with the frequency, with the voltage, with the current, with the reactive power that you want to inject into the grid. So they are key really to maintain the grid stability. And the more renewables are in the grid, the more DC loads we have in the grid, the more critical is how you really can play with the converters for the stability of the grid. And they are highly connected with the growth of the grid right now.
If we can touch upon BESS again, so battery energy storage systems, can you explain why they're so critical to the energy transition that we find ourselves in at the moment?
Okay, if we look into the International Energy Agency, they are looking that for 2030 there will be 6 times more battery storage than it is today. So this is the expectation, and there are 2 good reasons for that. One of them is that when we were studying at the university, they told to us, okay, you cannot storage the energy in the grid. You have to generate according to the demand. And the whole grid was about that.
Right.
Being able to generate according to the demand. So there were no way really to storage the energy. Now we have the capacity to store the energy. And we have the source of energy today, renewables. They really depend not on the demand. They depend on the weather conditions. So if there is wind, you have energy. If there is sun, you have solar energy. In the former grid, you were able to maneuver generation to adapt to the demand. Today, you have the energy when it is available. And then it's critical now to be able to store this energy so you can use it when there is a peak of demand or when it's really needed. So this is one of the critical aspects of battery storage. Second one is about the stability of the grid. So the more renewables we have in the grid, there is less rotating machines with a strong inertia, conventional generation in the grid, providing stability. So in the past, the stability of the grid was given by the large generators with a huge inertia, providing always the same frequency. Today, with more and more renewables in the grid, there is more fluctuation of frequency. There is more potential instability of the grid. We don't have these synchronous machines just keeping it smooth. So with the battery storage, you can provide with the right power conversion, you can provide this stability to the grid. You can use grid forming technologies, so you can compensate, or instead of following the frequency of the grid, you can really push some frequency to the grid. So it is necessary today with the current grids, with more and more renewables, to have this base of energy that can support the stability of the grid. So these are the 2 aspects. One of them is storage energy, so it's used when needed. The other one is really to provide the stability to the grid, since we have more and more renewables.
So these converters would act a little bit as the brain behind the operation?
Yeah, I mean, at the end, the battery storage or solar panels, they produce energy in DC current. It's not controlled. It's what they produce, what they get from the sun. And batteries, they can storage energy. Then you need to put a brain into that to be able to manage this energy in the proper way. So the power converters, through the conversion from DC to AC, is not only just a conversion, because there you can really define how much reactive power, depending on the grid's needs, you can push more reactive power, you can absorb reactive power, you can change frequency or support frequency. So the whole brain, it's in the converters. And as I said before, the more renewables we have, the more EV charging, the more data centers, the more DC currents, the more critical will be for the grid.
I know that still within the storage market, back in 2023, Hitachi Energy acquired EKS Energy. So why is this acquisition so important? Why was it such a milestone?
Yes, it was a gap in the portfolio of Hitachi Energy.
Okay.
Power conversion. So we are leaders in power grids, in equipment, transformers, high voltage breakers, delivering systems, power electronics, HVDC. So we are leaders in the market. And this medium voltage conversion, or this type of converter, it was a gap in the portfolio. Renewable energy is not old compared with power grids, more than 100 years. Renewable energy is 30 years old, something like this. So it was really pending topic, I do believe personally for Hitachi Energy to be in this part of the market. So it's essential because all the knowledge about systems, battery storage in the company, but we are lacking really this fundamental piece, which is the power converter.
Which we now have.
Yes, now we have it. So I cannot imagine Hitachi Energy in the future not having power converters in the portfolio. So that's clear to me.
Could you please share some examples of large-scale projects that showcase our leadership in storage and grid solutions?
Yeah. There are a number of examples. I will mention two of them. First one I will mention is Waratah Super Battery. This is in Australia, near Sydney. This is a gigantic. It's the largest installation worldwide. And the main reason for this installation was really to prevent outages in the area of Sydney. It's just to give you an idea about the dimension. It's 850 megawatts of power and 1,600 megawatt hours of energy, which is about the size of a nuclear power plant.
That's huge, yes.
It's huge. It's the largest worldwide. We're pretty proud of this, of course. And then the main purpose of that was really to be able to shut down conventional generation near Sydney plant that was there not because of the need of energy, but because of the need of stability to the grid. So now with Waratah Super Battery, we can really remove this conventional source of generation. It's supporting heavily sustainability in the area and providing the same amount of energy of a nuclear power plant to support the grid when needed. So this is really, we're super proud of this. Indeed, during the commissioning of the plant, since it is large, commissioning was taking a long time. There were an incident in Sydney, and the battery storage that we installed at that time, it was 1/3, I do believe. It was able really to prevent the outage in Sydney. So it's really a landmark in the industry. The other one is the opposite. It's much smaller in size.
Where is it? Where's the second one?
It's Faroe Island. It's in the Nordic. It's an island. It's a beautiful environment. In the ecosystem, they have wind, they have sand, they have a natural source of energy. So the purpose of the people there was really to move into 100% renewable energy, which is something that when you are in an island, is really a challenge because you cannot really, in case of any issue, you cannot really take energy from the grid. So it was beyond just delivering converter. It was really delivering a full system with combining wind energy, combining solar energy, combining battery storage for the moments where really they were not having the right generation to be able to pull for demand. So, and this is the other examples from the large one to one, the other example, which is a small one, which is really supporting sustainability and supporting the community in Faroe Island to achieve their goal, which is exceptional.
Earlier when we were chatting, you took us through the history of the power converter very briefly. So we went from being like a little analog thing where you pushed a couple of buttons to a more digitally enabled solution. What do you think comes next for power conversion systems? I
mean, we will continue supporting our customers in managing renewable energy, sustainability, and also supporting them in having an efficient consumption of DC energy, maybe charging data centers. We will continue. So in terms of future, power conversion is still a young technology if you compare with the rest of the power grid technologies, transformers, breakers, and so. So there is still a lot to develop. So from the point of view of pure power electronics, next step, which is now we are very close to that in the industry, is the use of silicon carbide. It's new material, new technology that will provide more efficiency to the grid.
Why is it more efficient?
The properties of the material. So it's are much more efficient compared with the silicon-based power electronics. So this is pure technology development. It's not application of, it's technology development. And now that we have this kind of material, we have to use that really to provide more efficiency to the power electronics. But then what is key also, because the power conversion is not just the power electronics, it's also the automation part. So we can imagine a future with artificial intelligence development of algorithms, because the more renewables we have, the more DC consumption we have, the more complex it is to manage the grid. So automation part is also key. And the last but not least, is digitalization. So digitalization of the electrical assets, the power converters that are the brain of the grid, really. It will allow us to have a more efficient operation for our customers, and also to move from preventive maintenance, which is based on calendar revisions, to a more condition-based services and maintenance, which is really the aim of that. So power converters, they have to last 25 years. And we have to be able to maintain those in a proper way. So it's in all the fields, in the pure power electronics, in the automation part, and in the digitalization.
How easy is it to maintain it? As in, you've just mentioned you're putting a lot of effort into R&D, which tells me it's evolving all the time. And it's a relatively new technology as well. So how hard or how easy is it to go in and do that preventative maintenance or, condition-based, as you just mentioned?
Yeah, it's much easier than the corrective maintenance when something happens.
And how often do you do it? Is it something you do once a month when you sell this product to your customer? Is it a whole package that goes in, okay, we give you the product, but we will also service it for you because we know what we're doing?
Yeah, I like the question because no, there are more and more our customers. They are interested not only in the initial investment, okay, procurement really of the equipment, but also how they are going to maintain the equipment over the years.
It is a more sustainable way of doing business, isn't it?
Yeah, of course. And for them, reliability is key also. So they don't want to lose generation. They don't want to lose the opportunity to pull energy from batteries. So we are offering to them, together with the offering of the converters, we're offering to them also long-term service agreements where we take care of the equipment for the next 20 years. So they can really rely on our services for that. For that is fundamental really to digitalize and to have data-driven maintenance. So we can monitor the converters functionality in real time. So we can really predict or prevent failures. So for that you were asking about, typically we do servicing once per year. So it goes from exchange of filter, which is very basic activity, to some checks of the electronics and the mechanical part. And through a data-driven services, condition-based management of the services, we can really do the maintenance when needed, not every year based on calendar. So we do have the solution, we do have the offering to our customers really to take care of the maintenance for 20 years. And I think that more and more customers are asking for that option because it's not only just to install the converter, run the PV, run the batteries. It's more about reliability. Yeah.
Just to wrap up, if you've got your customers listening to this podcast, to this episode, what is the one thing you would want them to take from our conversation today?
The power converters are not just a device they have installed. It's a critical device that they have installed.
Would you say they're strategic?
It's a strategic, totally strategic, yeah. It's the brain of the installation they have. So it doesn't matter how many panels they have, solar panels or batteries. The key is how the power converter is working in terms of operations, efficiency, and the reliability of the grid. So we continue working in R&D in power electronics to provide more efficient power converters. We continue working in automation side to provide to the customer more flexibility and reliability in the use of the converters. We continue working in digitalization of the power converters to provide them a more reliable and durable installation. So I think that renewable is growing very fast. And the power conversion technology has been also running together with the growth. But we are moving from maybe 20%, 15% of renewable energy in many countries or less to a dominant presence of renewable. So it's a critical and strategic asset to have a reliable fleet of power converters.
Thank you very much for coming in today and chatting with us. It's been wonderful hearing about your GPG.
Thanks a lot. Thank you for giving me the opportunity. Thank you.